Large language models, or LLMs, have become incredibly popular for tasks like recommendation systems, including something called bundle generation. Bundle generation is a marketing strategy where companies combine multiple products or services into a single package, often at a discount, to make things more convenient for consumers and boost sales for businesses. For example, you might see a telecom company bundling internet, TV, and phone services together. In this research paper titled, "Does Knowledge Distillation Matter for Large Language Model-Based Bundle Generation?" authors Kaidong Feng from Yanshan University in China, Zhu Sun from the Singapore University of Technology and Design, Jia Yang from Delft University of Technology in the Netherlands, Wei Fang from Shanghai University of Finance and Economics in China, Xinghua Ku from ByteDance Seed in Singapore, and Wenyuan Liu from Yanshan University explore how to make these LLMs more efficient for bundle generation. LLMs are powerful because they have vast knowledge and great reasoning skills, but they're also massive in size, which means they require a lot of computing power for training and using them in real-time applications. This can be a big problem for bundle generation, where you need to quickly suggest product bundles based on user preferences. To tackle this, the researchers turned to knowledge distillation, a technique that transfers knowledge from a large, complex teacher model to a smaller, more efficient student model. This way, you get similar performance without the high costs. The paper investigates three key research questions. First, how does the format of the distilled knowledge affect the performance of bundle generation? For instance, knowledge can be extracted in different ways, like simple frequent patterns, which are basically common trends in data, or more advanced formalized rules, which are structured guidelines, or even deep thoughts, which involve higher-level reasoning from the LLM. Second, they ask to what extent the quantity of distilled knowledge influences performance. This means looking at how much knowledge you need to transfer. Could be a small sample or a large accumulation from multiple sources, like different domains or by aggregating various formats. Third, how do different ways of using the distilled knowledge impact results? Here, they examine methods like in-context learning, where the student model learns by seeing examples in its input, supervised fine-tuning, which involves training the student on labeled data, and combining these approaches to adapt the model specifically for bundle generation. To answer these questions, the researchers propose a comprehensive knowledge distillation framework. This framework works in three main parts. First, it progressively extracts knowledge from raw data in increasingly complex forms. They start with frequent patterns, which are easy to identify from user behavior data, then move to formalized rules that turn those patterns into actionable guidelines, and finally to deep thoughts, which capture the nuanced reasoning of the LLM. Next, the framework captures varying quantities of this knowledge. They do this through strategies like sampling different amounts of data, accumulating knowledge from multiple domains, for example, pulling in data from e-commerce, telecom, and retail, and aggregating it across different formats to build a richer knowledge base. Finally, the framework uses complementary techniques to leverage this distilled knowledge. For domain-specific adaptation, they employ in-context learning, where the student model gets prompts with examples to guide its decisions. They also use supervised fine-tuning, training the smaller model on the distilled data to fine-tune its predictions. And often, they combine these methods for the best results, making the student model both efficient and effective for generating bundles. The researchers conducted extensive experiments on several real-world datasets to test their ideas. These datasets likely include user interaction data from platforms where bundling is common, like online shopping sites. Their findings provide valuable insights into how the format, quantity, and utilization of distilled knowledge shape the overall performance. For example, they found that using more complex knowledge formats, like deep thoughts, generally improves accuracy in bundle recommendations but might require more resources initially. On the other hand, simpler formats like frequent patterns are quicker and still effective for basic tasks. When it comes to quantity, adding more distilled knowledge through multi-domain accumulation boosted the student model's ability to handle diverse user preferences, though there was a point of diminishing returns where extra knowledge didn't help much. As for utilization methods, combining in-context learning with supervised fine-tuning often led to the best balance of efficiency and performance. This hybrid approach allowed the student models to adapt quickly to new data while maintaining high-quality bundle suggestions, all without the heavy computational load of the original LLMs. Overall, the study highlights the significant potential of knowledge distillation for making LLM-based bundle generation more practical. By carefully managing how knowledge is formatted, how much is used, and how it's applied, businesses can achieve efficient, high-performing recommendation systems that save on costs and resources. The paper is categorized under computing methodologies, specifically information extraction, and information systems like recommender systems. Key phrases include recommender systems, bundle generation, large language models, and knowledge distillation. The authors emphasize that this work could lead to more scalable applications in real-world scenarios, such as e-commerce platforms where personalized bundles are generated on the fly. In terms of the broader implications, this research shows that knowledge distillation isn't just a nice-to-have. It can make powerful AI tools accessible for everyday use, especially in fields like marketing and sales where speed and accuracy matter. The experiments demonstrated that even smaller models, after proper distillation, can rival the performance of large LLMs in bundle generation tasks, paving the way for more sustainable AI development. To wrap up the technical details, the paper was submitted to an ACM conference, with the full reference including the authors' names and the DOI for further reading. If you're interested in diving deeper, you can look up the archive version from April 2025, which is where this content originates.